Welcome to today's webcast presentation, Elements of Fabric Structures. My name is Bob Drake, editor of Civil and Structural Engineer magazine, published by Zweig Group. Thank you for joining this webcast, which is sponsored by Legacy Building Solutions. Before we begin today's presentation, first some general information about the webcast and the GoToWebcast platform. The views of the speakers and organizations participating in this webcast are their own and do not necessarily reflect those of Civil and Structural Engineer or its publisher, Zweig Group. If you have any technical difficulties while viewing this webcast, please submit questions or a brief explanation of your technical problem using the Ask a Question box on the left side of the webcast dashboard, and a representative will assist you. Note the button in the upper right corner to enlarge the slide viewing window if desired. During the webcast, you also can submit questions to our speakers using the same Ask a Question box. Submit your questions at any time, and we will try to answer as many as we can later in the webcast. Zweig Group encourages group learning for our events. If you are viewing the live webcast with a group on one registered person's computer, that person must complete and submit the multiple viewer registration form for the group in order for everyone to earn credit. Download the multiple viewer registration form from the event resources on the left side of the webcast dashboard. The mission instructions are on the form. Also note a link in the Event Resources section to download a PDF of the slides in today's webcast. Details on downloading a certificate of completion will be provided later in the webcast. Viewers of archived webcasts must pass a quiz in order to download a certificate of completion. Additionally, at the end of today's event, we will provide a webcast evaluation survey for you to submit your feedback. Presenting today are Nathan Stobbe, Eric Dene, and Dwayne Munch. Nathan Stobbe is General Manager of Legacy Building Solutions. He has more than 15 years of experience in the fabric structure industry and has made significant contributions, including as a member of the original committee for developing CSA S367, the guideline for pre-engineered membrane structures, and is co-founder of the Membrane Structures Manufacturers Association. He also holds several patents for fabric structure construction. As General Manager, Nathan leads Legacy's growth through innovation and vision. Eric Dene, Legacy Building Solutions Vice President of Sales, has more than a decade of experience in customer service and sales, plus more than 13 years of commercial construction experience. In his role at Legacy, Eric manages sales staff and processes and works to find creative solutions to customer requirements. Dwayne Munch is the Senior Structural Engineer for Legacy Building Solutions. Licensed in 26 states and 5 provinces, Dwayne oversees the engineering department, where he is vested with the responsibility of providing engineering analysis, technical expertise, detailing, customization, and retrofitting of fabric membrane structures. So let's get started. Eric, I'll hand it over to you to start.
Thanks, Bob. Today's webinar, you'll focus on fabric structures and fabric structure components. To the consumer, buildings are a unit, with all the materials plus construction purchased as a whole. To the engineer, it can be helpful to break the buildings down to the components and then assemble them, carefully considering each element of the building individually and as part of the system. Today, we will examine all elements of a fabric structure, including the construction material of frame, cladding, and foundation, and the building elements. You will learn the materials used in fabric structure construction, architectural features and alternative materials available for fabric buildings, factors that determine the quality and longevity of a fabric building, comparisons between engineered fabric buildings and engineered metal buildings, and how fabric structures are used for a variety of large-scale applications. Just a note, during today's webinar, we will be talking about fabric structures on a rigid steel frame. These are the buildings we are most familiar with at Legacy, and they are easy to grasp by building professionals as they have engineering considerations nearly identical to engineered metal buildings. First, we will focus on the defining characteristics of a fabric building, fabric itself. The biggest difference between fabric and steel buildings is in how the cladding material integrates with the frame. In a metal building, steel sheets are screwed to secondary members like purlins or girts, which in turn bolt to the rigid frames, creating an exoskeleton that actually aids the frames. In a fabric structure, fabric is attached to the frame via a keter rail, Though the fabric is a redundant brace to the frame's outer flange, it is not included when designing the frame. The purlings are the lateral support the ridge frame anticipates in the design process. Additionally, cables and steel rods are attached to the frame to transfer longitudinal wind forces through the roof and into the walls, eventually terminating in the foundation. Coated PVC fabric is one of the best-known architectural fabrics. Coated PVC fabric is made of a woven inner layer called scrim. The scrim is the basis of the fabric and provides the strength. In coated fabrics, such as Legacy's exclusive Exotech Elite PVC fabric pictured here, both sides of the scrim are protected by a primer, a protective coating, and a top coat lacquer. The primer layer enhances the bond coating. The top coat helps prevent UV rays from penetrating the inner layers, providing a waterproof barrier and provides protection to the scrim. The final layer of the fabric is a lacquer. The clear lacquer has two primary roles. It keeps plasticizers within the PVC from coming out and to provide a smooth, self-cleaning surface. Many PVC fabrics are also flame retardant in accordance with NFPA 701, large and small scale test, and California Fire Marshal requirements. Coated PVC is not the only architectural fabric available on the market. PE, ETFE, laminated PVC, and other materials are also available. The types of fabric vary in light transmittance, strength, and weight, as well as other properties. An experienced consultant will help you find the best fabric for your application. Standard fabric tests include the grab tensile, strength tensile, tongue tear, and weathering test. The manufacturer should have the results of these tests readily available for each of the fabrics you are considering. But the quality of the fabric is only one piece of the puzzle. How the fabric is treated during manufacturing and installation is equally important. Now, it's time to talk about fabric component manufacturing. Fabric panel manufacturing is the process of taking fabric from the manufacturer's roll, cutting it, and preparing it for attachment to the frame. Each roll of fabric should be inspected as soon as it arrives from the manufacturer. Any visible imperfections, including discoloration, should be immediate cause for removing the fabric from the manufacturing area. After the visual inspection, the standard fabric test should be completed. Once the fabric has passed all quality inspections, panel manufacturing can begin. Panels must be measured to tight tolerances that account for the precise amount of stretch present in a given fabric. Precision manufacturing is especially important when using individual fabric panels, as the size of the fabric is what provides the biaxial tension on the panel and prevents excessive movement and premature wear. Once the panels are cut and aligned, individual pieces of fabric are welded together using hot air, wedge, or RF welding systems. The strength of the fabric weld should be the same as the strength of the fabric itself. Once the fabric panels are manufactured, they can be rolled and packed for shipping to the building location. Where the fabric panels are manufactured is nearly as important as how. Fabric panels will perform best if the manufacturing facility is kept with proper temperature and humidity parameters to ensure the optimal weld strength, as well as proper panel sizing. Each panel should also be labeled with the location on the building before it is shipped. This will not only save a significant amount of time and confusion on the job site, it will help ensure that the panels are installed correctly. The next section is about the supporting structure for the building, or the frame. Permanent engineered rigid frame fabric buildings use the same rigid steel frame that is familiar to users of pre-engineered metal buildings. Rigid frame construction increases the structure's durability by enhancing how the frame carries vertical loads. The advantages of rigid frame construction include the ability to construct wide, clear span areas, engineering that complies with building codes, increased ability to withstand snow and seismic loads, increased ability to account for loads from crane, conveyors, and other point loads, and cost-effective and energy-efficient construction. I'll turn it over to Dwayne Munt to talk about the frame.
Thanks, Eric. Designers and engineers customize rigid frame buildings to meet the owner's specifications. The buildings are customizable to the necessary length and width with clear span interiors available to create more usable space. In addition to space requirements, customization options include door and window placement, eave height variances, interior build-outs, ventilation and heating systems, alternative wall materials, loading docks, and more. Customization options may be primarily practical or aesthetic. The ability to get a custom building designed around the business needs and preferences is one reason pre-engineered metal and fabric buildings are so popular. In fact, according to the Metal Building Manufacturers Association, pre-engineered metal buildings comprise nearly half of all 1- and 2-story non-residential buildings in the United States. While 1- and 2-story buildings are the norm for rigid frame structures, that's not a limitation. Balconies and mezzanines are one option for adding more interior space. The rigid frame opens up the possibility of overhangs, soffits, lean-tos, and other designs that are difficult and expensive to do with mass-produced trusses. While fabric structures with a second story are less common, it's an available option. Our office that I'm sitting in right now is a 2-story fabric structure. For many years, open web hollow tube trusses comprising tubular steel cords with tubular steel or steel angles placed intermittently between the cords to act as web members were the industry standard for fabric structures. Open web truss design is still in use by many fabric building manufacturers. However, there is debate in engineering communities about cord plastification issues in hollow tube trusses. Many of these concerns have not been adequately addressed by open web truss suppliers. Open web trusses are also difficult to customize due to the setting of uniform panel points along a truss cord. Hanging loads must be located at these points to reduce any additional bending that will be introduced into the cords. Loads that cannot be located at panel points will require additional analysis for this non-typical situation for truss loading. These types of loads will require additional time in engineering and drafting, and as we'll see on the next slide, they're also less suitable for corrosive applications. Hollow tubes pose a serious durability issue in applications where the buildings are exposed to corrosive conditions. Corrosion can originate inside the tube, out of sight and undetected, and corrode the frames from the inside out. Once corrosion begins, it can worsen quickly, and often the damage is irreparable. Fabric buildings using rigid I-beam steel frames are not vulnerable to internal corrosion. There are many flexible design options, and the frames can be used on structures that require large spans over 300 feet wide. Like all rigid frame buildings, these structures are designed and tested through a combination of sophisticated finite element analysis software and manual quality checks. The software allows designers to customize the work, make changes easily, provide timely estimates, and create sound design proposals and solutions. All buildings that will be in place for more than a few weeks are considered permanent and require a foundation. Reputable fabric structure manufacturers will be upfront about the need for a foundation and supply options starting at the first consultation. The earliest fabric buildings were temporary tents using temporary foundations such as ground stakes. However, these foundations are not a viable solution for permanent structures. Fabric structures, just like any pre-engineered metal building, are lightweight structures. The most critical functions of the foundation are to ensure the structure remains securely attached to the ground during wind events and that the base of the foundation does not push out when snow and wind loads are applied. While it may be tempting to settle for a temporary foundation to keep the building costs low, that compromise may lead to devastating consequences in the future as the building and soil shift and move. With the lighter mass of fabric, several foundation options are available, ranging from traditional cast-in-place concrete to less invasive earth anchors or helicals. Partnering with the manufacturer from the earliest phases of pre-construction may make it possible to reuse all or part of an existing concrete foundation, another way to save time and money during the construction process. The cost of a foundation is dependent on the building's size and location. Factors that influence the foundation design include environmental factors like snow and wind, soil conditions, water table and frost depth. Additional forces include the weight of the building and collateral loads. A thorough evaluation of all these factors is needed to assess and design the best foundation option for each building. Because ground compressibility can lead to excessive settlement differentials, similar or even identical buildings may require completely different foundations at different sites. Once the building materials are in place, it's time for installation. Here to talk about that is Eric.
Thanks, Dwayne. Installation is another key differentiator between fabric structure manufacturers. To begin with, there are very few installers that use a rigid steel frame. Installing fabric buildings is a specialized process best performed by factory-trained crews. This is an advantage of vertically integrated companies like Legacy, who use in-house crews to design, design, manufacturing, and installation. In Legacy's patent attachment system, each fabric panel, typically 20 feet wide, is secured to the frame using a Keter attachment system. The most important advantage of any Keter system is that it evenly distributes the pressure created by wind, snow, and fabric tension to every frame, not just the end frames. The Legacy Keter rail system allows for greater pre-tension on the width of the panels, which means more horizontal tension and longer lifespan for each panel. There is also greater vertical or up and over tensioning because the fabric is tensioned in a straight line, not around any radiuses. This increases the system's longevity, especially in cases of severe weather. In this system, a Keter rail slides horizontally on the top flange of the frame, eliminating the need to detach or flex frames during the fabric installation process. The extrusion is attached to the frame with half-inch bolts, eliminating the challenges of the tech screw while allowing for the very important horizontal tensioning after the frame is fully secured into place. Roof panels are attached together to create a waterproof, sealed exterior membrane. The system also uses horizontal mechanical tension to stretch the fabric to the recommended level, keeping it taut and preventing any friction for the life of the building. Using this system provides regular support and tension for the fabric both vertically and horizontally, which is critical to ensure a wrinkle-free finish and a long fabric life. Another significant advantage of this system is the increased safety during construction. Frames are completely braced and all cross cables are installed and tensioned prior to installing the fabric onto the building. The frames do not need to be flexed or bent as shown in the bottom rendering in order to allow for the fabric to be properly installed. Safety is always first during construction, a vital consideration on many commercial and industrial sites. With the elements of fabric, frame, and foundation in place, it's time to dive into the building components. The roof is a critical part of any building system. Fabric roofs have benefits in addition to the traditional roof function of providing a barrier between the inside and outside. Most fabric buildings use a white roof. White roofs have been shown to increase the energy efficiency of a building by reflecting sunlight and mitigating the heat island effect felt near clusters of buildings. The roof is also a source of natural light, which floods throughout a fabric building interior. But how does the durability of a fabric roof compare to a steel roof? The short answer is that fabric buildings are held to the same rigorous code requirements as steel or wood buildings. This includes snow load, occupancy, and hazard ratings. It also includes roof loads from additions like rooftop solar panels, which are mounted parallel to the roof to provide maximum sun exposure. The roof can also be the main source of energy for a building. Solar power combined with battery storage and a backup generator system may supply enough energy to completely eliminate the need for expensive grid connectivity. Combining a renewable power source with energy-efficient buildings allows reliable business operations in even the most remote locations, including far northern areas and mining sites. Here's an example of a building integrated power, our solar power system attached to the roof of a fabric building. This building, designed for solarship, has a 52 kilowatt array of 100 260 watt standard PV modules on aluminum racking mounted parallel to the roof. The building is designed to assemble and store aircraft and measures 176 feet wide by 231 feet long. The eave height is 60 feet, soaring to a peak height of 82 feet. And now I'll turn it back over to Dwayne.
Thanks again, Eric. The rigid frame building system gives the building walls several advantages. Unlike many open web truss systems, the walls of a rigid frame system are straight up and perpendicular to the ground. This allows for extra clearance of the sidewalls as the perpendicular surface doesn't interfere with shelving, tipping trucks, or other equipment at the edge of the building. Experience has shown that the sidewall is the area of metal or fabric building most likely to sustain accidental damage. In a fabric building designed with one large sheet of fabric covering the structure, the entire cover must be replaced if the sidewall is damaged. And since there is no clear separation between the walls and the roof, the damage can easily spread to the roof and leave the contents of the building vulnerable to the elements until the repair is completed. Using legacy system, if one or even two sidewall panels are damaged, the individual panels can be replaced without disrupting the other areas of the building. If damage is a concern, end walls and sidewalls may be constructed out of alternate materials, such as steel sheeting, glazing, masonry, or concrete panels. These alternate wall materials can provide added strength and security against external forces. When ventilation and accessibility are concerned, a pavilion building provides a dry, shaded area under a roof with no walls. Pavilions may be fully or partially enclosed as needed based on the building's use. Humboldt County Event Center in Winnemucca, Nevada is an example of a fabric building constructed with an alternate wall material. This structure is used to host a variety of equestrian and fairground events and features a fabric roof along with the steel walls. Combining these building materials gives the building owner the benefit of both types of building material. The fabric roof provides plenty of natural light and superior sound quality for the horses, while the steel walls are designed to blend in with existing structures and provide added security. In accordance with local regulations, this building is designed for a wind speed of 120 miles per hour. One of the most popular benefits of fabric is the fact that it has non-corrosive properties. But as anyone who's ever managed a corrosive storage building will attest, if even a small area of the building is vulnerable to corrosion, it can cause lasting and widespread damage. Fortunately, the other elements of a fabric structure can be designed to slow or stop corrosion. The fabric is a non-corrosive, thus eliminating the impacts of corrosion on the exterior building envelope. A vital step in corrosion protection is hot dip galvanizing the steel framing members. Every steel component, from the I-beam framing members to screws and fasteners, should be treated with hot dip galvanizing during construction. For the ultimate in corrosion protection, a fabric liner provides a continuous barrier between the corrosive material and the steel. Even the fine dust and particles are kept off the steel. Liners are permanently attached using a Keter system. All flaps are welded closed to create a solid barrier. Liners typically are made from fabric materials lighter in weight than the exterior building fabric. Access panels can be provided at regular intervals to allow the building owner to inspect the frame. Line buildings should have a separate ventilation system for the cavity created by the liner to prevent moisture from building up on the steel components. Corrosion is a major concern for some industries, for example, salt mining. This building for Lion Salt in Kansas is specifically designed to resist corrosion caused by constant exposure to salt. The interior liner keeps the steel frame separated from the salt, while access panels allow workers to inspect the frame. The liner is cleared to allow more light into the building, which, as you can see, is lit well enough for everyday use. Even with the liner, the frame is hot dip galvanized for more protection. Rather than steel cables, secondary support comes from solid bracing rods. Purlin caps stop salt from settling inside the ends of the purlins. Legacy crews install the building to OSHA and MSHA safety standards. Every building needs doors for access and egress. The number, size, and placement of doors will vary with the building's use. All rigid frame buildings have the same considerations for door placement, including sidewall clearance and header beams. Industrial overhead doors, bottom rolling doors, bifold doors, mega doors, and smaller options like garage and walk doors can be placed anywhere on the building. Jack beams are horizontal transfer beams that carry an intermediate frame that has had its sidewall column removed. The load is then transferred to the adjacent frames and their corresponding columns. Using jack beams allows the building to be safely supported with fewer vertical members. This creates extra wide openings, 20 feet or more between supports. Jack beams can be used to create sidewall entry points to allow for even the widest equipment, including mining trucks and heavy construction equipment. A good example of a building with multiple entrance requirements is this vehicle maintenance building in northern Manitoba. This building is part of a large hydroelectricity project and used to store and maintain a variety of heavy equipment and mining vehicles. It's outfitted with 7 roll-up rubber doors, while 12 service doors provide separate, safe access for personnel to enter and exit the building. The area around the entrances is protected from extreme weather by 3-foot overhangs outfitted with icebreakers, gutters, and downspouts. All buildings need ventilation systems to provide fresh air inside the building and to allow the building itself to breathe. In many applications, a passive gravity ventilation system consisting of an intake system and exhaust vents will create an adequate flow of cool, fresh air. Overhangs, which are available on rigid frame fabric buildings, allow for soffit ventilation to aid in the natural ventilation of the building or to provide attic ventilation in an insulated or lined building. They run the length of the building, eliminating dead spots in the center. Varying the widths of the overhangs will control the amount of airflow into the building. Rooftop vents ranging from open ridges to aluminum vents will allow the moist, warm air to exhaust out the top of the structure. Other ventilation options include end-wall vents, powered fans, and even open-air pavilions. When combined with the non-conductive properties of fabric buildings, ventilation may create a building interior that does not require any other climate control system. Ventilation systems designed to reach specific airflow levels are especially common in waste and wastewater treatment buildings, like this bottom ash dewatering facility in North Dakota. It measures 220 feet wide by 240 feet long and uses a hot-dip galvanized steel frame. The ventilation systems in this building, including exhaust fans and ridge vents, are designed to produce 6 air turns per hour. In one picture, you can see the interior equipment, most of which is already in place during installation. Hanging loads keep building features like lighting, conveyors, fire suppression equipment, heating and cooling systems off the ground and safely suspended and out of the way. Hanging loads from the frames leave the floor space undisturbed. The ease of designing framing members to support these hanging loads is another advantage using rigid frame structures. This structure for Smithfield Foods features several hanging loads. The overhead conveyor and filling equipment leave plenty of clear span storage space, a must for this bulk feed distributor. A staircase suspended from the building frame allows maintenance staff access to the conveyor as needed. Also visible in this picture is the liner, which prevents dust from settling on the frame, and the 10 to 12 roof pitch, which allows for taller feed piles. Fabric can also make the interior of the building more comfortable, as fabric has thermally non-conductive properties. Unlike steel, fabric does not magnify the outside temperatures, maintaining a more consistent interior temperature. Metal cladding will radiate the temperature variation, creating an interior that is colder in the winter and hotter in the summer. Flexible fabric also minimizes air leakage, resulting in a building which is much more efficient to heat or cool. Metal buildings are constantly contending with air leakage through screw holes and seams, which is another avenue of heat loss within a building. An independent study of an insulated fabric structure found it to be 157% more airtight than a conventional insulated metal building. Flexible fabric also allows for reduced air leakage through the wall assembly as well as fenestrations. Fabric structures are known for having minimal air quality issues and lower than average building heating requirements. Depending on the location and use of the building, insulation up to R30 is available. Insulation is installed between 2 layers of fabric. Because of the air tightness and thermally non-conductive properties already noted, insulated fabric buildings often cost significantly less to heat than comparable insulated metal buildings, creating long-term operating savings for their owners. Creating a comfortable interior is often the most important consideration for occupied buildings, like this multi-sport facility in Kimball, Minnesota. R30 insulation and an HVAC system allow this building to be used for sports practices and even indoor recess during long Minnesota winters. As you can see, the fabric liner also reflects and magnifies the brightness provided by the LED lighting system. fabric is especially well suited for the interior of this building, as the soft surface can prevent or minimize injury when an athlete collides with the wall. During construction, this building was attached to an existing brick structure via a fabric vestibule. Adding a lean-to is a cost-effective way to add more space to a structure. Lean-tos may be open or enclosed, may be separated from the building interior, or completely open. Specifying a lean-to gives clients more room for circulation paths, storage, office, or retail space, among other uses. Consolidated Grain and Barge uses a lean-to at their Naples, Illinois storage and distribution facility. One section of the building is in an unobstructed area for equipment, operation, and bulk storage, while the lean-to area is used for storing and distributing bagged product. The building owner chose fabric for this project because of its longevity in corrosive environments, as well as the natural light that will save on ongoing energy costs. And now to talk about some of the benefits of fabric, here's Nathan.
Thanks, Dwayne. So as Dwayne said, we're now going to talk about some of the advantages of fabric structures. So why choose fabric over metal buildings with a rigid steel frame? Here are some of the benefits of fabric. Building maintenance is a costly endeavor that is unfortunately necessary in many industries. Paint, shingles, siding all require regular maintenance to stay in working order and keep a professional appearance. Engineered buildings with metal siding or fabric cladding often avoid many of those requirements. Both pre-engineered metal and fabric buildings are built to last for decades. The engineering behind these structures makes them more likely to withstand everyday use and common hazards including snow load, strong winds, and seismic activity. Maintenance is one area that fabric structures often outperform steel. The steel sheets are inflexible and assembled with penetrations. Over time, this can cause leaks. Flexible fabric sheets are permanently welded together. Using Legacy's patented fabric attachment system, individual panels are sealed together with friction-fit overlapping seals to ensure that there is no air or water movement. Each roof panel is welded together to create a waterproof sealed exterior membrane. This system also uses horizontal mechanical tension to stretch the fabric to the recommended level, keeping it taut and preventing any friction for the life of the building. This system provides regular support and tension for fabric both vertically and horizontally, which is critical to ensure a wrinkle-free finish and a long fabric life. The advantage of sealed fabric roof system over that is that the cover is completely waterproof. There are no tiny holes from bolts or screws like in a metal building roof, which can allow for future drips and leaks. And because the panels are sealed together, there are no leaks at the panel breaks because of negative pressure inside of the building at the keter locations. In industrial applications, the give of the fabric provides some protection from collision. When the fabric is damaged, it's easy to repair by the building owner or by trained crews. Heat welding or simply patching will restore the fabric to nearly 100% of its original strength. Most repairs are completed quickly to minimize downtime and return to working order as soon as possible. Of course, all buildings are vulnerable to damage, whether from collision with heavy equipment, fire, or extreme weather conditions. Fabric structures using separate fabric panels ensure that in the unlikely event a section of the fabric is damaged, only the damaged area needs to be replaced. As shown in the picture above, a fabric building is self-ventilating. In the presence of heat or fire, the PVC will melt away from the flame rather than feeding it. Often, most of the damage from a fire is caused by excessive heat buildup within the building. In a fire event, the fabric melts away, allowing the heat to escape and drastically reducing the damage to the building. The ventilation also provides an escape route for smoke, which is one of the most deadly elements of a fire. The fire that occurred in the building shown above caused virtually no structural damage to the building, significantly reducing cost and downtime for its owner. Engineered buildings have shorter construction timelines than conventional buildings. This means the building owner can realize a faster return on investment by opening the building up sooner. Further time and cost savings are another advantage of fabric. Fabric panels are installed in about 1/3 of the time of steel sheeting, allowing construction crews to get in and finish faster. This also reduced the cost of wages, equipment rental, and living allowances during installation. Speed of construction is often a priority, like in this building for Pontotoc Sands Company in Oklahoma. This building measures 8,000 square feet and is on a cast-in-place foundation storing 20,000 tons of frac sand. Construction was completed in a very strict timetable, 6 weeks from the beginning of engineering through to manufacturing and construction. As it is a conductive material, steel transmits the outside conditions to the inside of the building. This places extra stress on the building's insulation and climate control system as they fight this conductivity to maintain a comfortable ambient temperature. Fabric has thermally non-conductive properties. While fabric isn't known for contributing to any insulative R value of the building, the non-conductive properties of fabric help maintain the interior temperature rather than magnifying the outside conditions. This case study features an insulated building that is climate controlled for year-round tennis play. The Oklahoma City Tennis Center at Will Rogers Park is one of the largest indoor tennis facilities in the region. It features R30 and R17 insulation, plus a quiet climate control system. The white liner both protects the insulation and reflects the LED lighting to magnify the lighting available for each court. This building is designed for high occupancy and meets USDA standards for tennis events and tournaments. The Tennis Center was named Municipal Facility of the Year by Tennis Industry Magazine, as well as the USDA Outstanding Large Facility. Like in many industries, there are widely varying quality standards among fabric structure manufacturers. Standard quality indicators like ISO 9001 certification are one way of judging the quality of the fabric building manufacturer. The building manufacturer should be able to explain every step of their process and the materials being used. Evaluating the materials, manufacturing, and installation is another way to determine if you're purchasing the highest quality building. And that's it. Today's webinar, we focused on fabric structures and fabric structure components. By examining all of the elements of the fabric structure, including the construction materials of frame, cladding, and foundation, and building elements, engineers and others involved in specifying buildings can ensure the building will meet or exceed specifications and expectations. Today we covered the materials used in the fabric structure, architectural features and alternative materials available for fabric buildings, factors that determine the quality and longevity of the fabric building, comparisons between engineered fabric buildings and engineered metal buildings, and how fabric structures are used in a variety of large-scale operations. And now I'll turn it over back to Bob to start fielding questions.
Okay, thank you, Nathan. Well, for the next few minutes, today's speakers will respond to some of the questions that were submitted. But please continue to submit your questions using the Ask a Question box on the left side of the webcast dashboard. So, Nathan, our first question is, are fabric structures suitable for earthquake-prone areas?
That is a very good question. I think I'm going to let Dwayne answer this one as he's our head of engineering, and he'd be able to describe it best. Dwayne?
Sure. Of course, with fabric buildings as well as metal buildings being found all over the world, we've had to deal with seismic concerns. It's been more of a focus probably in the last 20 years. It's just been more intentional about it now. But a lot of the factors that we get for our seismic accelerations come from the same documents that anybody gets them from, the S of S and S of 1 factors. So yes, we are designed for all the environmental factors, including seismic, and it's all site-specific. So we will, if we can't get that from a soils engineer, we can also look that number up ourselves and apply that to the structure.
The other thing I'll note is fabric structures and metal buildings generally have a light frame, which is very conducive for use in seismic zones. And the other unique feature about fabric buildings is the membrane flexibility, which really makes it an ideal building in seismic applications.
Okay, next question here is, what about post-fabrication hot dip galvanizing? This should address the interior corrosion you note on the tubular structure.
So that is correct. Some manufacturers with tubular structures do use post-manufacture hot dip galvanizing. Some of the challenges related to that is getting enough drain holes for the hot dip galvanizing to properly cover and penetrate all of the areas of the interior of the tube, but it is definitely one of the ways to try and overcome that hurdle.
Okay, next question. What is the fire rating?
So the fabric that is utilized in most applications is required to pass NFPA 701, large and small scale. And I realize that probably doesn't tell you a whole lot. The fabric itself is typically known as non-combustible with a 0-hour rating. And so if you go into the building code book, typically a fabric structure is going to be a type 2B building.
Okay. What type of insulation values do these structures provide for energy code compliance?
So that may vary a little bit from manufacturer to manufacturer. Here at Legacy, we have systems to allow us to insulate up to R30 and beyond, and allow us to do the appropriate energy code compliance evaluation to ensure that the structure meets that. The other thing I'm going to note, which isn't necessarily energy compliant relevance, the fabric structure has an interior liner which is extremely airtight. And we noted in the presentation, as compared to a typical metal building, they're often significantly more airtight, which eliminates air leakage, which is one of the greatest heat losses out there in today's normal building.
So what happens to the fabric in, say, minus 40 degrees C weather?
Good question. Fabric does remain flexible in those type of applications, and in fact there's extensive cold crack testing that occurs on the fabric to ensure that it does not crack at those types of temperatures. As a fabric manufacturer or a fabric structure manufacturer, we've installed buildings in both extremely hot climates, in the desert as an example, and in extremely cold climates in northern Canada or Alaska.
So how do these buildings hold up in hurricanes?
Yeah, also a very good question. If the structure is properly engineered, they hold up extremely well. Legacy Buildings, as an example, has done extensive hurricane testing on our structure and on our structure design, and actually have Florida product approval for our complete system to be able to be utilized in the hurricane zones.
Are the walls made in one piece?
Sorry, what was that question again?
Are the fabric walls made in one piece?
Typically, the fabric walls will be made in sections. Our normal section doesn't really go past about 100 feet. So every 100 feet you have another section of fabric wall system.
And what are the standard widths between frames? Are there any options for different widths?
Well, that's one of the great things about Legacy is we really have a lot of flexibility as it relates to frame spacing. Our typical frame spacing is 20 foot on center, but as Dwayne will attest, we've done many applications which have different frame spacing just based on the site engineering or the site requirements for openings or what have you.
Okay. Are live loads required for roof load criteria?
Dwayne, I'll let you answer that question.
Well, that's an interesting question. A live load can be defined a lot of different ways. Even snow load is considered a live load, but I'm assuming you're talking about something other than snow. Per code, per our ASC 7 code enforcement, we use live load, which is reducible. It starts at 20 pounds per square foot. It's reducible for square footage. So all our structures have that in all our load combinations, with all the different things that go together with them, dead and clatter, and all those other loads as well. So yes, our structures are designed for that, just like any other building.
So what is the minimum roof pitch to prevent rainwater accumulation?
Dwayne, you want to answer that?
Well, with our structures in the snow areas, we like to keep a more of a pitch than a minimum slope to drain water, because we want the snow to be able to shut off the structure, even though the structure is designed for full-time holding of that snow even through the winter season. But to get a minimum drainage off of a building, you're going to need, just like in a metal building, a half 12 to 112, and these would be areas where you wouldn't have snow concerns, because we don't want that flat of a roof in a snow area. But for as far as rain drainage, half 12 would be kind of a minimum that we'd want to see.
Do you have examples of fabric structures with fire protection, such as sprinklers?
Yes, we actually have many examples of that. Many of the projects that we work in have fire protection systems. In fact, if you look at the screen, there's two different types of facilities there. One is a soccer complex in Minnesota, and the other is a event center in Nevada, and both of those have fire protection systems inside the structure to deal with fire code.
So how long is your nominal custom design period?
Good question. Typically at Legacy, because we do all of the design work in-house and the manufacturing in-house, we can accelerate that design period. We would normally account for about 4 weeks for design, though depending on the project, that could take more or a lot less, just depending on the complexity of the project or the communication of information back and forth between the other professionals involved in it.
So can Legacy design a foundation?
Oh, Dwayne, you can answer that question.
Yeah, we certainly can. I would say we're just under half of all the buildings that we fabricate. We also come up with the foundation design plans that we create and then stamp and include with the building's drawings as well. And that can, of course, be the cast-in-place pier footing foundations. Under the right application with thickened edge foundations, drilled piers, helicals, and other types of anchorage like that that can be used, drilled piers, driven piles, and things like that. So we have been involved in many of those, and lots of times guys like to keep the foundation with the building, so they're just talking with one person. So that is something we offer.
Do these types of structures with separate panels experience any excessive vibration or noise during wind events?
That is a good question, and that, I think, has been a bit of a challenge for the fabric building industry in the past. It's one of the reasons that Legacy developed our patented fabric attachment system. What it allows us to do is create proper vertical tension on that individual panel, and then create horizontal tension so that you have a very tight fabric membrane on that building. And this really allows us to have very little fabric movement, even in a significant wind event.
So does the fabric add any rigidity to the structure that is counted on in the design?
Dwayne, you want to answer that?
Now that we actually had that. It was part of the presentation, but if you didn't catch that, but we do not count on it for lateral stability of the frame. It is certainly a redundant brace, but we use just like a metal building company. We have flange braces to purlins, and that's where we get our lateral stability. So the frame could have anywhere from 8 to 12 foot unbraced length, even though the fabric is there the whole time helping out. We don't count on that.
Could you explain the detail of the fabric connection to roof supports where it passes over?
Yeah, that detail actually showed an aluminum extrusion, and if you can picture that detail, there's two channels, one on each side of that extrusion, and the fabric panels slide through that channel up and over the roof system. So if you look at the pictures that are on the screen right now, the picture on the left, it actually shows basically a frame line every 20 feet, and that's where that fabric panel slides through that channel. And then we have an overlapping system to seal those two panels together to ensure a air and water leak-proof system.
Okay, we're going to go with one last question here. Could a legacy frame be recovered at the end of the lifespan, assuming the frames are still acceptable? And is this cost effective?
Very good question. Yes, it is definitely an option. In fact, most of the buildings that we're involved with, the customers are planning to apply new fabric at the end of the fabric life cycle. At Legacy, with our Exotech Elite product, we offer a 25-year warranty, and so at that point in time, it is a cost-effective way of not only replacing the roof of your building, but also giving it a brand new look, so that you basically refresh the look of that structure. At Legacy, we also have a recover division, which works to provide that support for other company structures as well.
Okay, thank you. So answers to all the questions that were submitted today, even those we didn't have time to answer, will be available online within a few days at csengineermag.com/continuing education. So please check there for further discussion about today's topic. As we finish up, please download your certificate of completion from the Event Resources section on the left side of the dashboard. After downloading the certificate, enter your name in it and print and save a copy of the PDF. Note that the certificate will be available only during the remainder of this webcast. A hard copy will not be mailed or emailed to you. If you missed our note at the beginning and you are watching the live webcast with a group on one person's computer, please download the multiple viewer registration form and complete and submit the form to receive credit. We need this information in case you are audited and we are contacted to verify this continuing education activity. Additionally, this webcast has been recorded and will be archived on csengineermag.com/continuing education. For viewers of archived webcasts, click on the quiz button on the event on the CS Engineer Mag website to take a quiz on the presentation. Archive viewers must pass a quiz in order to download a certificate of completion. As we conclude, you should see a webcast evaluation survey. We appreciate your feedback, which helps the Y Group and sponsors such as Legacy Building Solutions plan future webcasts. So thank you to Nathan, Eric, and Dwayne, and to everyone who joined us. This ends today's webcast.